Lesson 1, Functions Vocabulary. We are going to match each definition and term and then create an example or visual to help us remember more about the term. So the first definition is an input-output relationship that has exactly one output for each input. And that is the definition of function. So the thing to remember about a function is that it has exactly one output for each input. So we're going to make a list of ordered pairs: 5, -1, -6, 2, and 4, 0. So each input has exactly one output. 5's output is -1, -6's is 2, and 4's is 0. So X does not repeat. Okay, the next definition, the value substituted into a function. That is called the input. Input is put into a function. So in an ordered pair, X, Y, X is the input. Okay, the value that results from the substitution of an input into a function is an output. In our ordered pair, it would be the Y. The form of an equation used to graph a line is slope-intercept form. And it is Y equals mx plus b, where m is the slope and b is the y-intercept. And that's why it's called slope-intercept form. The measure of the steepness of a line on a graph is the slope. And a ratio that compares the amount of change between two variables is called the rate of change. Okay, these can both be represented the same way using slope-intercept form. Y equals mx plus b. So m, we know, is our slope. You can also call that the rate of change. And you can find it two different ways. If you're doing slope on a graph, m would be the rise over the run. And if you're doing it algebraically, it would be y2 minus y1 divided by x2 minus x1. All right, now we have where the graph of a line intersects the y-axis, and that is called the y-intercept. Intercept and intersect. And then the starting point where x equals 0, or the y-intercept, is called the initial value. Just like your initial is the first letter, it is the starting point of your name. Okay, so we're going to use y equals mx plus b again, where b is the y-intercept or the initial value. Okay, so it would be wherever X is 0, then Y is the Y-intercept, or the initial value. On a graph, it would be wherever it intersects the Y-axis. Okay, a function whose graph forms a straight line is called a linear function. Straight line, linear. So it might look like this. Okay, a function whose graph does not form a straight line is nonlinear function. Nonlinear, not straight line. Can look all different ways, but let's do this. Draw a curved line. Okay, page 2. Okay, first definition, a plane formed by the intersection of an x-axis and a y-axis. That is called the coordinate plane. The horizontal axis on a coordinate plane is the x-axis. Just like you cross X, horizontal goes across. Okay, the vertical axis on a coordinate plane is the y-axis. Just like you go up and down to create a Y, vertical is up and down. You go up and down to create a V. The 4 regions into which the X and Y axis separate the coordinate plane, those are called quadrants. Quad means 4 regions. The point where the x-axis and y-axis intersect on the coordinate plane. So that is called the origin. Okay, a pair of numbers that can be used to locate a point on a coordinate plane. That's called an ordered pair. All right, now let's use these terms to label this diagram. So the whole thing is called a coordinate plane. Okay, this axis that goes across is the x-axis, just like you cross an X to make it. The axis that goes up and down is the y-axis, just like you go up and down to make a Y. Okay, this point right here where the 2 axes intersect, this is called the origin. Zero, zero. It's the ordered pair for the origin. All right, let's talk about the quadrants. So we know that it's 4 different sections. This first section right here is the one that you learned first how to graph in, and this is quadrant 1. Yeah, you use a Roman numeral 1. looks like an I. Okay, then the quadrants go in counterclockwise order. So from quadrant 1, we're going to go over here to quadrant 2. And again, we use a Roman numeral 2. Okay, continuing in our counterclockwise, we're going to go to quadrant 3. Roman numeral 3. And then our final quadrant, quadrant 4. That looks a little different. So in Roman numerals, this V stands for 5, and this 1 is to the left of it. So it's 1 less than 5, which is 4. So this is quadrant 4. That's how it's written in Roman numerals. Okay, this is what is called an ordered pair. Ordered pairs are written X, Y. So there's a point, an ordered pair that represents this point. Okay, let's do more with our ordered pairs. So I'm going to zoom out to the bottom section. Okay, so we're going to find the ordered pair for point A, this one that we were just talking about. So I'm going to start at my origin, and I'm going to go across first, just like you go across a lobby to get on an elevator, and then you go up and down. You always go across first. So on my x-axis, this would be +1, +2. And then I'm going to go up 1. So that'd be a +1. So 1, 2, 1 is how I'd write that ordered pair. 2, 1. Okay, and it is in quadrant 1. Roman numeral 1. Point B, right here. So to get to point B, I'm going to start at my origin. I'm going to go across 1, 2, 3, and then I'm going to go down. And it is in quadrant 4. Point C right here. So I'm going to again start at my origin. I'm going to go to -1 on the x-axis and then up 3. So -1, 3. And it is in quadrant 2. Point D, start at my origin, -1, -2, -3, -4, -5, and then down 2. So that ordered pair is -5, -2. And it's in quadrant 3. Okay, so let's find these other points by using the ordered pairs. So we're going to go to -4, 2, start at my origin. -4 would be here. And then +2 would be right here. So again, -4, +2. That is point E. And it's in quadrant 2. Okay, next ordered pair is 1, 2. Start at my origin, I go across 1 and up 2. So that is point F. And it's in quadrant 1. Point G is located at 4, -1. So I'm going to go to 4 on my x-axis and down 1 on the Y. And right here is point G. And it's in quadrant 4. Point H is located at -5, -1. So here's my origin. Go to -5 and then down to -1. So that is point H. And it's in quadrant 3. And that is the vocabulary for their unit on functions.